Scaling Up Nation, Trace Blackmore here with some mind-blowing news that'll make your job a whole lot easier. 3 industry titans, Masters Company, Radical Polymers, and MFG Chemical have joined forces to create your ultimate one-stop shop for your water treatment needs. We're talking over 60 years of Masters Company's expertise in private label products and cutting-edge test kits. Radical Polymers' game-changing Inisha additives, and MFG Chemical's custom manufacturing prowess. These American companies are bringing you top-notch quality and reliability all under one umbrella. From blending and ultra concentrates to specialized polymers and custom solutions, they've got you covered. And with multiple AWT Supplier of the Year awards between them, you know you're getting the best of the best. Ready to revolutionize your water treatment game? Head over to scalinguph2o.com/MFG. Once again, that's scalinguph2o.com/MFG. Trust me, you'll be glad you did. If your sales meetings feel like just another meeting, it may be time to raise your sales curve on purpose. Lauren Real knows that new sales is life to a water treatment company, and he helps teams build the skills and habits to make that happen. Using simple, real-world case studies from water treatment and collaborative discussions, Lauren shows salespeople and managers how to manage opportunities, ask better questions, and move prospects to decisions. He offers sales training, keynote talks at sales meetings and conferences, and consulting specifically for water treatment companies. Lauren is available to speak at your next water treatment sales meeting or conference, or work directly with your team in a training or consulting role. And if you don't feel his session was useful, his speaking or consulting fee is 100% waived. Learn more by visiting scalinguph2o.com/realwater. Once again, that's scalinguph2o.com/realwater. Real sales training, real sales motivation, and real sales experience. That's Real Water. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm your host, Trace Blackmore. And Nation, I want to thank you because I've received several comments where people were thanking me for just 2 weeks ago. I answered questions that were about me. And I shared with you, I don't like talking about myself. And that's something that I'm trying to do better with because you want to know more about the host. And I heard that from so many people that I needed to give some more personal information, maybe even invite some questions about me. So we did that very thing. 2 weeks ago, I did that. It was very therapeutic for the host. It wasn't as bad as I thought it would be. And so many people enjoyed it. So thank you for encouraging me to go out of my comfort zone. I hope that was exactly what you were hoping for. I did enjoy having that conversation with you. And again, I want to thank you for all the people that made the comment that I need to do shows like that because it helps you enjoy this podcast more. So if you have an idea for this podcast, let me know what it is. It might be like the idea we just did 2 weeks ago. I might not like it, but I hear it from enough people that I know I need to do it. Well, Nation, we've got an incredible interview for you today. And I want to tell you, I love talking with people that have been in this industry for a while. They've seen things, they've seen changes in things, they've seen good things, they've seen bad things, and they want to tell the story so they can make all of us a little bit better and this industry a little bit better. And that's exactly what I have for you today for the interview. But before we get there, I do want to mention a couple of events. And the first one that I will mention is the American Waterworks Association Annual Conference and Expo, ACE 26, is taking place June 21st through 24th in Washington, D.C. This is a huge conference all around water professionals. So be sure to go to scalinguph2o.com. Check that out, and we make it really easy that you can go from scalinguph2o.com in our events section and then go straight to where you need to register and find even more information out about this event. And also, I want to mention the Water Expo, the 15th edition, taking place August 12th through 13th. And that's taking place in Miami, Florida. What a great place to go. Nice and warm. Great things to do in Miami, and all things around wastewater, sewer infrastructure, pipe rehab, water quality, filtration, irrigation, software, finance, and a tremendous amount of networking. So go ahead and check that out as well, and all of the other conferences that we have, that all you need to do is go to scalinguph2o.com, go over to our events section, and you will be amazed at how much is going on in our industry. And what I don't want to happen is there is something that is taking place in your backyard that is going to help you in your professional career. It's going to help network you so you can meet new people, and you miss out on it because you didn't know about it. That is horrible. And I know how busy you are driving from account to account, and you don't have time to individually find these individual seminars and conferences and trainings. Well, folks, the team here at Scaling Up H2O have made that very easy for you. Simply go to our webpage, and we have every conference that we know of listed right there for you. Speaking of somebody that's trying to make it easy to learn and have fun while you're doing it, here's our friend James McDonald with a brand new Words of Water.
Hello and welcome to Words of Water with James, the industrial water game show where I give you the definition and you get to guess the word or phrase being defined. Will you rise to the top or get blown down to try your luck another day? There's only one way to find out on Words of Water with James. Today's definition is the standard SI unit for the amount of substance defined exactly as 6.02214076 times 10 to the 23rd elementary entities such as atoms or molecules. Can you guess the word or phrase? The answer is mole. Okay, for those who got it correct, step to the right. For those who got it wrong, please step to the left.
Excuse me, sir.
Yes, Igor?
If you will remember, the basin has been drained, so we can paint those little sharkies you wanted on the side.
Oh yes, I do remember. Sorry folks, no blowdown today. I'm James McDonald, and I look forward to seeing you next time on Words of Water with James.
Well, thank you, James. Nation, now is the part you've all been waiting for. Here is our interview. Today, my lab partner is Brad Buecker of Samco Technologies and Buecker and Associates. Brad, welcome to the Scaling Up H2O podcast.
Thank you, Trace. It's a pleasure to be here.
Well, it is a pleasure to have you here. You and I think, met on LinkedIn, and you have participated with our weekly challenge for a while now. You've been the winner of our weekly challenge for a while now, so congratulations on that.
Well, thanks. I think it's just I wake up early and I always plug into LinkedIn first thing, and the questions a lot of times right there. So I think I'm just getting a jump on some of the other people.
Well, I got to say, you've got some pretty in-depth answers. You're not just saying one-word answers. You're really going into why that's the correct answer. So I think you know what you're talking about.
Well, thanks.
Well, Brad, do you mind introducing yourself to the Scaling Up Nation?
Okay, I'll go ahead and do that just to give a hopefully kind of a brief background. I started in the industry, actually in the power industry in 1981 in my hometown of Springfield, Illinois, and I ended up spending nearly 2 decades at two coal-fired utilities, water treatment, steam generation chemistry, air emissions control, flue gas desulfurization, and some results engineering. So a lot of experience there. I spent 2 years at a chemical plant as a water and wastewater manager, 11 years at two engineering firms. And then for the last 8 years, I've been with two water treatment companies, one that supplied chemicals, and then here recently, hired on with Samco that manufactures water treatment equipment. So, kind of in a nutshell, that's my work experience over that time, almost all of it, nearly 3.5 decades. I've been very, I'll say, interested, but have enjoyed technical writing. And I've written for a lot of the trade publications over those years: power engineering, water technology, chemical engineering, power plant chemistry, and so on and so forth. So that's a kind of another facet of my experience over the last 4 decades.
So, speaking of those 4 decades, what are some of the big lessons that have really shaped how you think about water and steam chemistry today?
One of the first ones, really the most important one, is safety. I know it's emphasized a lot, but it really is because in the power industry and in so many other industries, you're dealing with a lot of high energy systems. Temperature, for one, flow is another one, moving equipment. And really, people do need to be vigilant at all times when they're working around equipment. Be aware of your surroundings, follow lockout tagout procedures and a confined space and those things. The SDS forms that go with chemicals. People need to treat chemicals with the proper respect. And then, of course, wearing proper PPE. So it's just something that, and it's not just me, it's my colleagues too, that we try to emphasize is keep safety in mind first. Quite honestly, just the other day on LinkedIn, there was a post by a woman. I don't know how old she is now, but she had a picture of her there with her father. And when she was 8 years old, one day he went off to work and he didn't come home. And that's the ultimate. So yeah, we gotta keep an eye on those things. Another aspect, and I've seen this over the years at various industries, is moving beyond the phrase "that's the way we've always done it." I mean, human nature is to just relax and, yeah, let's just maintain the status quo. But looking at our industry, like the membrane technologies that have developed for makeup water treatment, changes in high pressure steam generation chemistry, cooling water treatment improvements. So those are, three of the things that I've worked with over the years. And I know that there are a lot more.
You've created a lot of content, and one of the articles you wrote really got us to start thinking that maybe we were clinging to some outdated concepts that were creating some bigger problems than maybe the ones that we were trying to solve. Do you mind alluding to that?
Yes. And I have two here. I know we're going to get into this in more depth here in just a minute, but putting my power plant hat on, flow accelerated corrosion. And it's a very serious issue that a lot of people still don't understand. So we can talk about that here in just a minute. And then the mindset that I've seen so often at places where I worked and then had colleagues tell me about numerous times is the water is water mindset. And and quite honestly, and I've written a couple of articles about that, saying water is not water. And it stemmed from a couple of very funny TV commercials in the 1980s about motor oil is not motor oil. And I won't go into depth on them. People can find them on YouTube, but they're hilarious. But so often, and I've even heard operators say that when you talk about, oh, we need to do this treatment technique or we need to make this change. Ah, water's water. Just put it in the boiler and let's go. Well, that can be a recipe for disaster. So those are two of the big things that I guess I get up on my soapbox about because they're still prevalent.
Well, I'm going to give you more of an opportunity to get up on your soapbox. Let's go ahead and unpack those. When it comes to flow assisted corrosion, what can you tell us?
Okay, well, I'll try to give you somewhat of a background here, but not go into the weeds too far. But when I started in the industry, and that was back in 1981, it was almost carved in granite that, okay, for well, any steam generator, but when I started in the power plant, it was the high pressure steam generators. You don't want to have any oxygen in there at all. We got to get it out. So every unit was equipped with a mechanical deaerator and then also supplemental chemical feed, ammonia, or sometimes an amine for pH control, which is still important, but also a reducing agent oxygen scavenger to clean out that last little bit of oxygen. And at the time, hydrazine was used. Well, there were all issues about carcinogenic effects of hydrazine. So other products were developed. But the core idea was we got to get all the oxygen out of there. Okay. Well, in 1986, this was actually at a nuclear plant. And EPRI's done a ton of work on this. And this is what really got everything energized. There was a failure of a feed water line at this nuclear plant, a sudden catastrophic failure that released high temperature feed water, which then flashed to steam once it reached atmospheric conditions, and it killed 4 personnel.
Oh, wow.
Okay, yeah, we're talking serious things here. Well, these failures have happened in fossil plants over the next 20, 25 years, whatever, including a failure at a sister plant to one where I was working back in the mid 2000s. So this is really hitting home. I mean, it's bad enough that these failures are causing fatalities and injuries, but when it hits a company where you're working, that is really close to home. Well, EPRI in their research, what they found out was, I'll backtrack just a little bit. This program that had been developed that, like I said, was kind of carved in granite with a chemical feed, it was designed to produce oxide layers on the carbon steel piping network for these feed water systems. And then a lot of the big coal fired plants that were constructed back in the middle of the last century, they had complicated feed water systems with a number of feed water heaters, and very often these were tubed with copper alloys. And copper does not like the combination of oxygen and ammonia. It'll eat it away, dissolve it away pretty quickly. So this chemistry was required to protect the copper alloys, but they also thought that, okay, it's putting this oxide film on the carbon steel, it's protecting the carbon steel. Well, what was not known until failure in 1986, when they started investigating, is that at flow, and the term sometimes used as disturbances, but that's kind of incorrect, but like elbows, changes in flow, and economizers in boilers have a whole bunch of elbows. And now in the heat recovery steam generators and combined cycle plants, these evaporators in there, you have circuits with a lot of elbows in there. But at those and other fittings, the combination of flow, this chemistry, which is known as all volatile treatment reducing, or AVTR, plus some other factors, including pH and temperature, will cause a gradual dissolution of the protective layer right at that spot. And it just the wall just gradually thins until it can't handle the pressure anymore, and then you have a catastrophic failure. So you can have 2,600 psi water, and I'm thinking back to one specific incident, 2,600 psi water around 500 degrees that all of a sudden just bursts from wherever the failures occurred, and of course flashes to steam. And, you know, anybody in the area, basically, you can't escape it. And that's what's happened. So EPRI did a lot of work in this, and other research firms have as well too, to figure out what the mechanism was. Well, even before that, this is clear back in the 1960s to early 70s, over in Europe, for supercritical plants over there, and I won't go into all the details of those, But chemists found out that with those plants, if there were no copper alloys in the feed water system, which apparently a number of them were designed, with either stainless steel or maybe even carbon steel feed water heater tubes, that they could actually direct or inject a small amount of oxygen. And you have to have very high makeup or high purity makeup water and feed water to do this. But if you have the high purity feed water and you inject a small amount of dissolved oxygen, you can actually get a more dense, tighter oxide layer on the carbon steel in the system that protects it and protects it against FAC. Well, when this failure occurred here in the United States at the nuclear plant, one of the things that EPRI did was they started looking at that chemistry, and they came up with it eventually was adopted over here for more supercritical plants. But EPRI came up with another program. Its acronym is AVTO. It's similar to oxygenated treatment, but you use basically the oxygen that leaks in at a steam condenser on a unit and maybe with a little bit of injection. But they developed that for drum units. And I actually was at my second power plant, and we had EPRI come in and we converted a 720 megawatt coal-fired unit from AVTR to AVTO. So we did that, but that's designed to minimize or eliminate FAC and stop this and basically protect the plant and protect the plant personnel. So that's really kind of where this has gone over the last, well, since 86 is the research into it and programs to control it. It's just there are a lot of people that still haven't recognized this. So that's why I've written a number of articles about it and talked about it. There are experts out there, a lot of experts, but like Dr. Barry Dooley, who was with EPRI and is now uh, back in England and is heavily involved with the International Association for the Properties of Water and Stream, and Michael Jiha, who's with power plant chemistry. He's a noted technical expert. These folks have been going around the world for years trying to alert people to this problem because it seems like even at new plants, the personnel are locked into the old method and they're running AVTR when they should be running AVTO. I know Dr. Dooley, I remember hearing him in a presentation he gave, and this has been a number of years ago, but he had been on a tour of a number of new combined cycle units, relatively new combined cycle units, and he said that the heat recovery steam generators in these units, when we investigated, they were suffering severe FAC just after 3 years of operation. So, this stuff can cause problems in a big hurry. And when you're talking about potential fatalities, I kind of get excited about it.
You want to make sure people know.
Yes, absolutely.
You mentioned a couple of your articles. If you share them with us, we'll be happy to put those on our show notes page so we can even get the message out there even better.
Okay, I will do that.
Since I have you, you mentioned oxygen scavengers, and we have people in the Scaling Up Nation that have been in this industry for decades and some that have just started out. Do you mind maybe talking about the different oxygen scavengers? Maybe we talk about hydrazine that you mentioned, maybe sulfite, maybe DHA.
Yeah, and they have different purposes. For high pressure units, well, let me back up. Sulfite was used and still is as an oxygen scavenger in low pressure, maybe low pressure and medium pressure units. But it's what's known as a non volatile oxygen scavenger. It's a mineral, sodium sulfite. So it goes into the boiler and it does its thing in the boiler, but that's okay. But when you get into utility boilers, the high pressure, one of the big things is, and again, I don't want to go too far into the weeds, but a very important concept with high pressure utility boilers is what's known as steam attemperation. You try to keep the superheat and reheat steam within a narrow band, based on the boiler design and so on and so forth. Well, to do that, typically a small amount of water is injected into the steam, and that comes from the feed water line in the boiler, which is high purity. You can't use sodium sulfite because then you're basically putting a mineral deposit right into the steam. So these volatile compounds were developed to help scavenge oxygen and provide the reducing agent. And basically, the first one was hydrazine, N2H4. And it can do the job. And actually, especially at my first power plant, that's what we were using. But it concerns arose because it became a suspected carcinogen. So the water treatment companies, and of course, they want to sell their products, but they started coming up with alternative compounds. Probably the most common one that's used most often was carbohydrazide, and essentially it's basically hydrazine with a carbon dioxide molecule added, but it's much safer to handle, at room temperature and that kind of thing. Much safer for power plant operators and chemists and so forth to handle, load it into the mixing stations and pump it into the system. It then will break down to hydrazine in the boiler, but at that point, you're not breathing it or anything like that. And then there were some others that were developed, like the DHAs and the methyl ethyl ketoximes, and I think it was people companies that were looking for, they wanted to be in the market too and come up with products. So I'm not going to claim that one's better than the other, but, people were looking for products that they could sell that were alternatives to hydrazine. So that's really kind of how that developed.
Well, the other item that you mentioned was the comment where people will say, water is water. We, of course, know that's not the case. What that essentially means is water is the last thing they're thinking about when you and I think it should be the first thing that they should be thinking about. So, what do you want the Scaling Up Nation to know the next time they hear the phrase, water is water?
Well, you brought up a great point right there. Is it's the last thing sometimes that industrial plant people think about, when it really should be the first thing, because the plants can't run without water and steam. If your boiler goes down, now large industrial plants, it might not shut down the whole plant, but it could shut down a unit operation. It could be very costly. So, yeah, there needs to be more focus on that. And I've been involved both directly and have observed plants, and also have had some tremendous stories told to me by colleagues too about some things that go on. But probably the first item that I say that I've noticed, it's not just me, it's people, for years that have noticed. A lot of the industrial plants have low pressure or intermediate pressure boilers, and all that's really needed for makeup is sodium softening, ion exchange sodium softening, just to get the hardness out of there. Hardness is a big killer. And then maybe a downstream decarbonator to take CO2 or bicarbonate alkalinity out of the water too. And most recent ASME industrial steam generator guidelines, I say the most recent, it's in the previous guidelines too. If you look at the kind of the limits or the range of limits in these guidelines, low pressure and intermediate pressure boilers can tolerate a fair amount of dissolved solids. Now, the range decreases as pressure increases. That's just natural. But the one compound in there that's has a low limit and it decreases to very low limits, but starts off even at a low limit, is hardness, calcium and magnesium. Because when it gets into boilers, even low pressure boilers, obviously there's still plenty of heat in there. It will react primarily with bicarbonate alkalinity to form CaCO3 scale. And this has plagued so many steam generators over the years. And where that kind of ties in with the water is water mentality, and makeup treatment is so often if somebody, and I've actually seen colleagues that have said that when a company calls us in and says, we're having problems with our boilers, we're having boiler tube failures and that kind of thing. So the first thing I'll look at is the softener operation. And so often people will find either there was a big failure or more often it's repeat. excursions. Somebody hasn't maintained the softener, it's overrun, hardness has gotten into the system. And I know a picture that I've used in a couple of my articles shows a boiler tube, and it just shows I say several, maybe a dozen individual layers of calcium carbonate scaling where the softener messed up. So you got CaCO3 scaling, then they got it running again, then it messed up again, and so on and so forth. So that's kind of the big issue a lot of times with the water mentality. I didn't experience this firsthand, but I've had a number of colleagues over the years, very reliable colleagues, reliable information. Were servicing large industrial plants. A couple of them were refineries where the softener system went down and plant management said, just bypass it. We have to keep running. And that can lead to some catastrophic failures. So now all of a sudden, and it goes back to your point about water being so important. All of a sudden, the boiler has failed and needs retubing, which takes time, money, and everything else. But the unit process goes down. So the costs for operating for, say, maybe a day while the softener was being repaired are, the return on investment is extraordinary, extraordinarily bad, I should say, not good. So it wasn't worth it. And I had this in my notes too, and this was a somewhat different situation, but the effects were the same. And I was a direct observer of this. It was a utility boiler, but it was only 1,250 psi, so almost like a medium pressure industrial boiler. But it had just come up from a scheduled maintenance outage, a month-long scheduled maintenance outage. And when they brought it back online, and I was actually in the chemistry lab then, we said, you've got a condenser tube leak. You need to take the boiler off and find it. Oh, no, we're selling power. We're selling power. So we tried to keep the chemistry, as good as we could with this leak going on. And they ran for about 3 weeks like that. And then finally shut the unit down because we kept insisting. They finally shut the unit down. Well, as it turns out, it wasn't an actual failure. It was another issue that let this cooling water in. But about 2 or 3 months later, that boiler just started blowing tubes like mad. They'd have it on for a few hours and another tube would blow. And it was due to a phenomenon called hydrogen damage. And I won't go into all the details of that. But they had to retube the entire boiler. So for 3 weeks of selling power, then they ended up having to retube the boiler. And that was a real eye-opener. That and another event later on was a real eye-opener for management and really started to take them away from the water is water mentality.
Well, Brad, let me ask, because I know you've got lots of experience with this. You know what's going on, or at least you have a really good suspicion of what's going on. You tell the customer, they're, of course, are the ones that own and control the equipment, but they're not listening to you. Maybe it's because, hey, we're selling a product. We can't afford to do that, or at least that's their mindset. They don't know the other expense that they're avoiding. I guess they're not avoiding it. They're going to come up with it later. How do we convey that better with our customers?
Sometimes it just takes a failure to do that, similar to an intersection. Sometimes it takes some car crashes before, people will put in street lights at the intersection to stop that. Sometimes it takes a failure. Sometimes plant management is receptive to it. And when you start explaining what can happen, there's understanding. I think for the people that are reluctant, about all I can suggest is explaining these case histories, trying to point out what's happened. And there are so many of them. Some people are going to, maybe the issue is going to dawn on them. Some people, maybe not. Maybe it is going to take a failure to really convince them.
Scaling Up Nation. We're going to take a quick break to hear from one of our sponsors. Today, I want to talk to you about a hidden threat lurking in your cooling water systems: biofilm. You know, that slimy stuff that causes all sorts of headaches for us water treaters. But don't worry, because I've got some great news for you. Our friends at AMSA have developed products that are absolute powerhouses when it comes to biofilm control. These aren't your typical products used in biofilm control programs. Oh no, they're much more than that. AMSA's products actually penetrate and break up those stubborn, gluey deposits. This means your biocides can work more effectively and at lower levels too. Plus, it weakens the biofilm matrix, allowing it to be washed away with the flow of water. By incorporating AMSA products into your biofilm control program, you can say goodbye to your concerns about microbiologically influenced corrosion, scale formation, reduced cooling efficiency, and even minimize the risk of Legionella in your systems. So if you want to clean it up and keep it clean, head over to scalinguph2o.com/AMSA to learn more about their innovative biofilm control solutions. Once again, that's scalinguph2o.com/AMSA. Trust me, your cooling water systems will thank you. A special thank you to all of our sponsors for their support. Now, let's get back to our interview. Well, another topic you write about is proper layup. And for whatever reason, it's suggested, but it's not done. What are some of the issues that can happen with that? I'm sure a lot of our listeners have already experienced them. And how can we change those conversations to hopefully have better outcomes?
Well, that's a very good point. And one of the things that I noticed, that a lot of my friends noticed too over the years, was even at plants where management focused on or hired the staff to focus on normal operating chemistry, and oh yeah, let's keep an eye on operating chemistry and maintain the pH where it needs to be, and that kind of thing, and watch for any leaks and stuff. If a unit would come offline, okay, we'll just shut it down, just leave it standing there. Of course, the water in the system cools. Any points of air entry come right in, and so now all of a sudden you've got the perfect combination for localized corrosion, and of course carbon steel, and we can drive around and see severe corrosion when we see things rusting. So now it's just happening on the inside of the tube surface rather than on the outside, but you have localized corrosion with this water and air that leaks in. And so the idea behind good layup procedures is to protect all surfaces from, basically that's the biggest problem with layup, is protect it from oxygen and water corrosion. Several different ways to do that. If possible, if you know it's going to be a long-term layup, and sometimes they aren't, of course, if maintenance work is being done on equipment and on tubes, you drain the unit, but you need to drain it completely or dry it out, and that can involve some specialized procedures so that you're not dealing with the moisture and oxygen combination corroding the tubes. And there are methods to use dehumidified air to dry out equipment. When a unit's coming down, if you start the draining before it reaches what would be the atmospheric boiling temperature, if you're still at maybe 5 or 10 psi or so, and start draining, things will flash dry. And I won't go into depth of all these things. There are methods. A good friend of mine that used to be with a combined cycle power plant, he's now with EPRI, but they had set up a system. This plant was on and off all the time, following load. So they couldn't really drain it to protect it because it would need to come back up very quickly. So they actually installed a nitrogen generator at the plant, and they would cap the unit with nitrogen to help protect it that way. And it was a nice open space, but you have to start thinking about confined space issues and that kind of thing, because nitrogen's not poisonous, obviously, but it can asphyxiate, people if you get in an area where the air's not there. But they set up that system. They set up a dry air humidification system for the condenser and the LP turbine, because that's another issue. People might say, okay, we're going to protect the boiler. Well, you need to protect the low pressure turbine, and don't just leave water standing in the condenser. There's a lot of areas to look at here. And I won't say recently, these products have been around for a while, but they're being improved and finding more use are what are known as vapor phase corrosion inhibitors that can be used both in wet and dry environments. And they actually will produce a volatile compound that is attracted to metal surfaces, and it will form a layer on the metal surface and protect it from the water and air that are on the outside. So there are a number of methods to do it. It's just people need to take the time and do the research and contact the firms to go ahead and do that. Don't just leave things standing full of water and think it's going to be okay.
And then, of course, when something happens, when in doubt, blame the water treater.
Absolutely. Oh, I've been there. I've been there. It must have been the chemist's fault.
Now, another one of the articles you wrote is when we have corrosion problems, people get into materials of selection and they look at stainless steel and they say, hey, this must be the cure all for all my corrosion ailments. And of course, not water is water on this one, but stainless steel is all stainless steel. Would you like to talk about that?
Oh yeah, absolutely. And it's very true. Now there are a lot of stories that have come out of the chemical industry where people have fabricated vessels and stuff out of some stainless steel. There are quite a wide variety. And then the particular chemical in there would cause attack. But from the water side, and this was a big issue that I ran into for a number of years. I was one of a group of people that would review kind of the requests for proposals that came in for a new combined cycle power plants. That was pretty much the industry. And most every one of them included a cooling tower. So this had come through, and invariably the specification would say either 304L or 316L stainless steel, and the L stands for low carbon, but that's kind of beside the point. And I've had the opportunity over the years to pick the brain of a materials expert, Dan Janikowski. I actually just talked with him today. He's mostly retired, but I just talked with him briefly today. But as research came along or developed over the years, it kind of worked down to where they kept lowering the limits for chlorides in the water to prevent pitting. And this is the key. This is the key corrosion mechanism. Stainless steels develop an oxide layer for protection. But there are certain elements, and chloride being one of them, that will penetrate the oxide layer and establish pits. And pitting is really one of the worst forms of corrosion, probably the worst form of corrosion you can have, because the corrosion will just go straight through the metal, and you can have through wall penetrations without a whole lot of metal loss. General corrosion, you may get more metal loss, but it's over the entire metal surface, so it takes a long time before you reach life expectancy. So you can get pitting. Well, pretty much, and I'm trying to remember the numbers, the last numbers that Dan told me, but I think I have these correct, is they kind of worked their way all the way down to about 200 parts per million for 304L stainless and about 500 parts per million for 316L stainless. Now that's clean tubes. That's not tubes with deposits on them. That can cause problems in and of itself. So we'd get these RFPs that would come in here, and the water might have, it might have 100 or 200 ppm in it. Okay, if it was once through cooling, that'd be all right. But we've got a cooling tower now where they're going to cycle it up 4, 5, or 6 times. And then we'd get into cases. This is a whole different story, but we get into cases where, because of environmental regulations, they were mandated to operate at maybe 10 cycles or higher. So now all of a sudden you've got chloride concentrations that are way above what are recommended limits for pitting. And these design firms that produce that, nobody knew that. They said, "Oh, it's just going to be stainless steel, 316. Yeah, this is great. Let's just put this in there." So then we'd have to get into arguments with them about, well, you're looking at some potential problems here. So, and I would see that occur over and over and over again. So that's one of the biggies.
Lots of things to unpack. You write some great content. Another one that I wanted to bring up is you wrote about a particular company's standards and how they specified a pipeliner and cleaning method that didn't really match their process conditions.
Oh yeah, and this is actually a two-part story. I won't reveal any names here, but
Will protect the innocent and not innocent.
yeah, it was a new simple cycle power plant, meaning just combustion turbines out on the West Coast. And they put in like 9 of them. Well, you don't need water normally for combustion turbines. And that's another case history I can talk about, but I'll do that in a little bit. You don't normally need water for combustion turbines, except on these units, they had a water cooled heat exchanger on the combustion turbine inlet air compressors. You have to compress the air to then push it into the combustion turbine. So they had these intercoolers, they called them. They were 2-stage air compressors and these intercoolers on there that required water. So it was set up on a closed cooling water circuit. Okay, we don't really have to add water. We just circulate the water around with an air-cooled condenser. I mean, it was great big, whole bunch of fans, and the water moved through coils in the fans, but you had basically no water makeup at all. So it just kept circulating. Okay, that sounds like a good idea. And out in the West where drought conditions can be pretty severe at times, yeah, we don't want to use up any water. So one day, and it was a colleague of mine and I, and he'd helped me out on another project that I had on my list that I haven't even mentioned. But we got an email. We'd first heard from an engineer out there saying that the air cooled condenser was not performing well. It seemed like there were flow restrictions. And then we got an email from another engineer out there said, well, we broke open one of these coils in the air cooled condenser, and there's a whole bunch of black material, dark black material in there. So we're gonna go ahead and schedule a chemical cleaning for iron. And both my friend and I, we replied almost at the exact same time. Whoa, 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 whoa. How do you know it's iron? Have you analyzed for it? No. Well, then don't schedule a chemical cleaning. So we both went out there, and they brought in the pumps on this system. The circulating pumps had strainers in them, metal strainers. So they brought in a chunk of this black material from the metal strainers, and I said, "Boy, that doesn't look like iron. Can you get me a beaker or a cup of either gasoline or turpentine?" Yeah, sure. So they came back with a cup of gasoline, and we threw that chunk of material in there, and it just immediately dissolved. Okay, this is not iron oxide. So my buddy did some research, and what we found out was that standard material for this big trunk line that serviced all these things, the standard material for it was ductile iron with an inner liner of concrete with another inner liner of bitumen, basically tar. And after investigation, what we found out was when they had all the units online, the cooling water got warm enough that that bitumen just came off and started circulating through the system, which clogged the air cooled condenser. So one, that was an incorrect specification for materials, for the pipe. And a basic question I asked was, why didn't you use ductile iron and we could have treated it chemically? There are good corrosion inhibitors you can use, nitrates and molybdates and things like that. And of course, that would require investigation. But the second part of it was they were just going to go ahead and do an iron cleaning when the contaminant was an iron. And one of the things, the timing turned out well in this because they had another big project lined up and they had specified the same material for a very similar project. And we were able to figure out before they started using that for the trunk line on the next project. But that was quite an incident.
Well, it seems like this one worked out. Your customer listened to you. You had the expertise to prove that it wasn't iron. But there are a lot of times that people have checklists and procedures that just don't match what's really happening. And they want to run those procedures, they want to run those checklists. How should we have conversations like that with our customers?
That's a good point. I guess from the 40,000-foot view is just don't make a general assumption. You can never make a general assumption. You've got to have the data. You need to do a due diligence, get some proper data. I'd probably use the example I just gave you. If I were talking to a customer and saying, okay, you just can't make a knee jerk reaction or just an assumption. You really need to do some analyses and figure out what's there because, in this case, this would have just compounded what turned out to be basically a seven-figure mistake regarding the material installation, but it could have been another seven-figure mistake if they'd chemically cleaned it with the wrong cleaning solvent. So for me, and I maybe it's because I'm so old, but all these case histories, in talking with clients, I think I'd just start pulling out some of these and saying, okay, you want to do this, but you can't make that assumption. You could cause yourself many more problems by just making a general assumption.
And I think experienced is the word you were looking for, not
Yeah,
not the one you
experienced.
used.
Yeah.
Well, and let's hit on that experience. You've seen so many things. You knew that you could use gasoline as a solvent and figure out whether it was iron or not. There are a lot of people listening today that they don't have that kind of experience. What should they do?
Well, this gets into a very interesting issue, and I know some of my colleagues and I have talked about this before, and the fact that experienced people are retiring. I'm at that age where I could, but I'm not going to for various reasons.
Good, because you write some great stuff.
And I enjoy it so much. But for people, managers, and then for actually their plant people, they really need to be thinking about this and try to get their people training in this. Now, they don't have the baby boomers like myself. A lot of us are leaving. They don't have them to talk to. But and my recommendation is, okay, if you don't have the people there, go to the places where there are people where you can network, like the AWT conferences, the International Water Conference, the Electric Utility Chemistry Workshop that I've been involved with for years and years and years. That was started in Champaign, Illinois, way back in 1980, I think, either 80 or 81. We just recently co-located with PowerGen. We're there. Go to these conferences. There are always good presentations and papers given there, but also network with experienced people that are there. There are always a lot of good vendors too that are there. Make the connections. Don't just try to guess at what to do. Try to find the people you can talk with to get some good information.
You alluded to a huge problem in our industry. So much knowledge is getting ready to exit through retirement. One of the things I try to really stress on this podcast is that mentor protege relationship. Do you care to speak a bit on that?
Yeah, I think it's very important. I just wish people would avail themselves more of it. This has actually been probably about a decade ago or so, and it was a company where I worked, and I won't name any names or not, but when I was there, we had a great lab staff, with several degreed chemists. And we were able to keep track of a lot of things going on. This is when steam generation chemistry was really starting to evolve. And we were learning things. Well, this is in the mid teens, long after I was gone and my colleagues were gone and stuff. And this goes back to the EUCW, which was in Champaign at the time. The lab supervisor where I formerly worked got up and gave a paper, and this was a year after the event, where they had to derate their largest unit through the entire summer because they were having chemistry problems. And nobody in the lab, and he was a good guy and he was not unintelligent, but nobody in the lab had the training to understand what was going on. And I almost started spinning a hole in the floor listening to this. Well, about a year later or so, I had a chance to visit with him. So I actually made a trip back to the plant to discuss another project. And I started talking with him about that. And I was with one of the engineering firms then. And I just basically asked him, I said, if that had happened when we were there, management would have just been chewing our behinds like mad. You don't derate a unit in summer. That is cost a utility so much money. And they ran through the entire summer with the unit being derated. And I said, and it's not like I'm Einstein. I won't rip off my shirt and, I have an Einstein shirt underneath it. But I just asked him, I said, why didn't you call me? Because he talked about reading my articles. I said, why didn't you call me? We could have discussed this and maybe figured out what was going on. Well, and I can't remember what his reason was, but, he didn't reach out. And so I guess that's what I'd tell young people. There are people out there that will help you. If you ask questions, if you need help, there are people out there that will help you. And, a number of the water treatment firms, they have good people. They have knowledgeable people too. Now, that in my own experience, that can be variable depending on the individual representative you get, but there are knowledgeable people out there that can help. You just got to reach out to them. Don't try to muddle your way through because it can be difficult.
Well, I think a lot of people are scared to reach out because that's a heavy lift. Hey, do you mind helping me with this? I've never met you before, but I've read your article. You've got no reason to help me. So if you got a call like that, how would you handle it?
Well, what I learned is I started moving through the industry is yeah, I needed help at times and was very appreciative of the help that I got. So basically just try to reverse that. Okay, if somebody needs help now, given job responsibilities and things like that, I couldn't necessarily, just offer a whole bunch of free hours over the time, some general consulting and stuff, sure, but I would never, I'm not going to turn down somebody that calls and say, hey, I need to know something. Well, let's talk about it a little bit and, see if we can figure things out. Or, if I didn't have the time to devote to their project, is get them hooked up with somebody that did.
Brett, I don't know if that's unique to our industry, but I have never asked a similar question to anybody in our industry, and they have ever said they would turn down that individual. Everybody is so willing to help and share knowledge and raise the bar in the industry. It's a hard question to ask if you're younger and maybe lack experience, but it is so worth it. And again, I've never heard anybody say no.
Right. There are a lot of good people in this industry. There really are. Yeah. And I had the pleasure to know a lot of them for a long time.
Wow, what an interview. I love interviewing people on this podcast that have decades of experience and they love to talk about it. So, Brad, thank you for being that person. And as you already know, Brad and I had a lot more to talk about, but we couldn't cover it all this week. So stay tuned for next week for part 2, where Brad's coming back and we conclude our interview. But this episode was so impactful on why safety and accurate chemistry and a willingness to change really matters in high pressure boiler and steam systems. And Brad had so many examples that he's had firsthand experience in. Now, we mentioned a lot of his technical papers. We're going to mention even more next week. Don't worry. And if you haven't read them, you really should. He is a great technical writer. We're going to have all of those listed on the show notes page for the ones that we mentioned this week. Of course, it will be on 477. And spoiler alert, next episode is going to be 478. So when we release that, we're going to have all of those show notes as well. Now, part 2, Brad's coming back. We're going to dig in deep to oxygen scavengers, to pre-treatment stories. We're going to talk about his career. You're going to get a lot of great information. So make sure you tune in next week for that episode. Until then, have a great week, folks. Achieve your goals with the Rising Tide Mastermind. Set your sights on success and let us help you get there. Our mastermind group provides the accountability and support you need to achieve your personal and professional goals. To find out more, go to scalinguph2o.com/mastermind. Once again, that's scalinguph2o.com/mastermind. Find out if the Rising Tide Mastermind is right for you.